channel, and today we will be talking about abstraction, and the first thing in the abstraction comes interfaces. So basically, an interface is set of rules, it's set of contract that you can implement on different classes. So let's say whatever the rules you define inside an interface, all the implementing class will have to follow that. So I'll show you by an example. Let's just create a new Kotlin file and interface. Let's say we can name it. Let's take example of the shape. So let's say we can create a class interface named shape, and inside this shape there is this one function that we can write, and let's say that is calculate area. Okay, so this method will actually return a double. Cool. So I have written this method. It means that this method, if any class that implements this method will have to be overridden, and the class should have to follow that. So let's say I create a class name as circle, and what I'll do is I'll implement the shape that I created. So once I do that, you can see that the circle class says that you need to implement it. So let's say if I have to implement it, this set of rules will be overridden. It means that I added a rule over here as calculate area, and when I implemented that interface on a class, it forced me to have this rules implemented over here. So uh, let's say for a circle, the formula for circle is pi r square, and for that what we need is we need a r or radius. So I'll create a radius as double, and for initially I'll set it like this. Okay, and now if I have to calculate the area, what I'll do is I'll go to math dot pi into radius. So this is a class that I have created. Let's say I add one more function over here, is that I say that print data. For example, I created this function in I wrote this function in the interface, and now if I come over here, it will again ask me to implement the second method as well. And now over here what I can do is I can just print, let's say print line, and I'll say calculate area. So this is how you can use an interface, and the major difference between basically or let's say, yeah, okay. So the interface can also be like inherited or derived from other interface. Let's say you have another interface that you want to drive from. So let's say I create another interface called as base interface. Okay, so the base interface will have, let's say this base interface have this function. I'll take this shape class and this function, I'll take out this function and put it inside over here. Okay, so and then in the shape what I can do is I can also drive it from the base interface class, and it will be the same. If I take it out, it will ask me to implement that method. So it's just like a class. You can also inherit one interface from another, and the class that is basically inheriting or sorry implementing the interface, it have to basically override all the methods. So basically, what is an override? We are actually talking a lot about this functions. So basically, what is an override? You might have seen that we have been doing, like we have been implementing a lot of overrided functions. So when we are talking about an override method, what does it mean is that, like, let's say you have a function that is written in a parent class or defined in a parent class or a interface in this specific case like this. So basically we have this function which is defined over here, and on the child section where basically we are implementing those, what we want to do is we actually add the implementation for it. So override function is basically a function that is being overridden. Like there might be an implementation in the parent class or in the parent class, or there might not be an implementation, but that function is defined in the parent class, and then you want to have a different implementation for each child class. I'll show you with another example. Okay, so let's just create a Kotlin class name as triangle, and I'll implement it with shape. Now it will ask me to implement the methods. Now let's say for a triangle, what we have is we have a var base as double. I'll set that some default value, and then we have height. Okay, so we have base and we have height for a triangle, and now we'll be calculating the area of a triangle. So basically the area of a triangle is base multiplied by height. So it's base into height divided by 2. So we have a different implementation. Now let's say we have this specific parent section where we have a calculate area which is defined. Now in the circle we have overridden the method from the interface, and we have added a different implementation over here in this circle. And for triangle you can see that we have a different implementation. So the override method basically helps in when you have a parent class and then the child class have different methods, so sorry, different implementation or different ways of working. Then what you do is that you override the parent class method, and then you add a different implementation for whatever implementation you want. So that's the difference. And over here, let's say for a print we can also have some other different implementation. Let's say I'll add a triangle area is, and then I'll add the calculate area function. So this is how an override function works, and this is how an interface is also works. The next thing will be abstract classes. So what is an abstract class, and how we can use it? We have seen that we have already used some sort of abstraction over here by using an interface, but we also have another way of like defining the abstraction, and that is abstract classes. So what is an abstract class? Normally it's like really similar to what we have as a interface. The major difference between interface and base class, sorry, an abstract class, is that the abstract class can maintain the state while the interface cannot maintain it. So that is the major difference between the abstract and interface. And plus what I believe is that when you have some set of rules that you want to define, and that set of rules can be implemented on different type of entities. For that purpose you can use an interface. And when there is something concrete, like in term of a very specific thing, and there can be some state maintenance issues, so for that purpose you can use abstract class. So now we'll be talking about abstract class, and then we'll try to um, create some example for that. Let's say I'll create another. Let's just get rid of this. Now let's just create a Kotlin file, and I'll name it as food. So created a food class, and now I want this class to be an abstract, so I'll add an abstract keyword to it. It means that this class now cannot be instantiated. So let's say if you remember, we used to create objects, let's say, and like this. So what we can do is we cannot do this, and once we do, if we try to do it, it will also tell us that you cannot create an instance of a abstract class. So you cannot create an instance of an abstract class. Normally these classes are just used to be implemented by other classes to have some set of rules and some properties defined. So let's say for each type of food, each type of food can have some calories, and each type of food can have a name, and then there can be each type of food can be eaten as well. So we'll define some properties. Let's say I'll define a property as variable calories, and those calories can be integers, and I'll add a null to it. Okay, now the next thing is to name integer, and sorry, it should be string, and the string can also be null. Now we have these two things, and now there is one function that I can use, and that can be consume. So these are the things that we have done. Let's say I'll add a function implementation to it as well. Now I have this abstract class which with some properties, but I actually cannot use it. So how I'm gonna use it? Let's say I'll create another class. Now what I'll do is I'll inherit this class. So I'll create another food class. Let's say I'll go for a burger, and I'll create this class, and then implement food. Now once I do that, the first thing is that I'll have to add a constructor implementation. For an interface we don't need that, but for a class, abstract class, you have to have this construction. Now you can see that over here what I can do is, let's say if I let's say let's keep it like this. Now I have this burger function and then this food thing. Okay, in the main, let's just try to implement the function, and let's just try to implement the class. I'll create a var food equals to burger, and now you can see that the food dot calories can also be updated. Food dot name can be set to, let's say I'll add a zinger to it, and now if I add a food dot consume, I can also call this method. Now the interesting part is that I have created a burger class. You can see that, and these properties are coming from the abstract class. They're not directly inside this. So basically also this is one of the classic example of inheritance as well. Now you can see that there is not much difference between a normal interface class that we implemented previously and this abstract class. So what are some extra properties that you can use, and we'll talk about that. So basically an abstract class actually gives you access, or gives you a possibility to define abstract variables and abstract functions that basically forces the implementing class to implement those methods. Let's say I'll give you an example. Let's say for each class that I'm going to create, I want the calories to be overridden. So since every class have a different calories, I want those to be defined. Now what I'm gonna do is I'll create an abstract. Let's say I'll add a wall to it so that it's a non-changing property, and I'll just take it out. Okay, so now this is one thing. Let's say I'll also add the non-nullability as well from this, and now abstract as well. So what I did is I added an abstract to it, which means if I go to this burger class, now it will ask me to implement those properties as well. So if I, you can see these two properties are there, and also you can see that override methods are overriding it. Now I'll add 100 to this thing, and for the name, let's say I'll add a zinger. Okay, now I'm gonna, over here what I'm gonna do is I'm gonna take it out, and this consume method right now doesn't have anything. So let's say I'll print something over here. Let's say let's print ln eating, and then I'll add the name of the, okay. Now that's these are the thing. Now let's just try to run it and see what happens. So if I run it in this section, you can see that I am eating a burger. So what I did is this. Now let's say the consumption, the way of consuming things can be different for each food. So what we are going to do, for example, let me give you an example. What I can do is I can create another class, and I'll name it as juice. So I created a class juice, and now I inherited it from food. Now it will ask me to implement those two variables that I defined. Let's say I'll name it as 200. For the name, we can name it maybe, let's say go for juice. Okay, now for food it's fine, for a burger it's fine that a user is actually eating. But let's say if I change this variable to juice, and now if I run it, it will say eating juice, which doesn't make sense. So what we are going to do is that we are going to add our own implementation for juice. For that we'll be using override. So I'll go for override, and I'll, first of all, sorry, remember I mentioned previously as well, the first thing is that we need to open this function as well, so that it can be overridden. By default these are closed function or final function, they cannot be overridden. So the first thing is to do is to open it. If it's not abstract and you want to implement it, sorry, override it, then you need to open this. Same goes for the class. If it's not abstract, then you have to open the class to implement it, so sorry, to inherit it. Okay, so now what I'm gonna do is I'll consume function, I'll override that consume function over here, and now over here what I'm gonna do is I'll add print ln, and now I'll be saying drinking, and then the name. So now if I run it, you can see that now in spite of eating, it's saying drinking, which is fine. And that is how you can basically have different implementation. Now there is one more thing which is, let's say I'll just take it out, and I don't want this function to be like defined or implemented. I can also make it abstract. So once I do abstract, I also have overridden over here, but in the burger I don't have it. So the burger class will keep on saying that you need to implement it, and once I do, I can do it over here. Now there is a huge discussion related to the interfaces and abstract class, when to use when. So there can be different ways, that as I mentioned as well, on how and where to use these. Let's say you have some behaviors, and that is irrelevant of the type of classes that you have. So for that purpose, what you are going to do is you can use an interface. And if the behavior is relevant to a specific type, let's say the behavior is relevant to a human, it means that you can go for a abstract class. So that is one of the thing. And when there is a scenario where you have to implement multiple behaviors or multiple classes, since the Kotlin can accept only one parent class, so what you can do is that you can create interfaces and implement those interfaces, multiple interfaces on a specific class. So that can be one thing. Other than that, there is some scenario where you need to have some abstract method and some non-abstract method along with some abstract property or non-abstract properties. For that purpose, you can also consider abstract class. So that's it for today, and I'll see you in the next video. Please don't forget to subscribe.